can see, we are plainly back in the tested office.
And everything works.
Does it?
Oh, yeah.
If you use your imagination, it's all here. But no, Zach kindly brought everything over.
He was a lifesaver.
A total lifesaver.
Yeah.
And now we are putting everything together, and we've done quite a lot of fitting of all the pieces, and I think that we're in pretty good shape. We know the path forward now.
Yeah, we had to do the correct spaces for the TV, which was a whole thing because we discovered the Visa mount on the TV is not completely centered, so there was a lot of flipping around.
Right.
We
had to enlarge some holes.
Yeah. A few of our cleats that we put in were a little off, so some tabletops, the panels are sitting crooked. Fix those.
Live and learn. It wasn't like we had to recut anything.
No. As far as all of our main pieces, everything is great.
Yeah.
The fact that I modeled everything for 0.75 thickness, and these ended up being 0.71 has been messing us up a little bit. Yeah, but nothing that we can't deal with. Now, we did do one major thing, which originally these fins were going to bolt from the bottom, but we realized that going into the end of this MDF, lightweight MDF, bad idea. So we put a bunch of brackets in on each one so that if you grab it here or grab the fins,
you're basically lifting the whole thing.
Yeah, it sets on the fins, it'll be nice and strong.
Right.
That was easy to do.
Yeah, so the only thing is the TV is not in there. So we have to disassemble everything to get that TV in there. But once that's in there, the idea is that will all live inside.
Yeah. Oh, hey, and did you see we got our subwoofer?
No, I did not see that, actually.
Yeah.
This is great. So this has a built-in amplifier. Please tell me it has a built-in amplifier.
Sure, why not?
Okay.
Yeah. It has to.
Yeah, it's very heavy.
This is interesting because this was, we were trying to figure out what to do for the subwoofer. This is a car one that's meant to slide under the seat, and it fits perfectly in the base. So it's just going to sit on the very bottom of the cabinet, which I think will be perfect.
Excellent.
So down there, whoop.
So we also got the very beginnings of the LED panel in there. So we had a couple thoughts on how this was going to fit. Like we didn't know if we were going to make a bracket that mounted to this outside layer.
It's been a thing.
And also like what supported the outside layers. Then we thought, well, why not combine them?
Yeah. So first, Jeremy, I want to commend you. This looks so fantastic.
Well, and this is not full brightness. This is 1/16 power. It's not the number of LEDs. Testing.
The bar graph thing, I cannot believe how good this works. And the trick was that you separated each spine and you used frosted, right?
My hope is it extends the screen. Like, it just has the illusion of making the screen bigger.
So this is obviously our test panel for the inner, and these are my first go at brackets. So we don't have a lot of 3D printed stuff on this one, but these are obviously 3D printed.
Love it.
So the idea, you had done a pass on it, and I took a lot of inspiration from that to have these little arms to support the LED ribbon. And then we've got we got a black backer that just drops in, your little fingerboard, and then a little spacer. And then the idea is that when you put the front panel on, we have inserts, heat inserts that I just use a soldering iron to sink into the plastic.
Yep.
That will sandwich everything and hold it in place and also kind of make this rigid and keep it from twisting.
These little inserts you have here that screws actually go into properly, that is the extra mile that you go to, Sean.
And they go right in with soldering iron.
That's super cool.
So right now I just have these tacked and you see it moves. So we're gonna actually have two bolts that go the whole way through and hold both brackets.
Not unlike how this is secured.
Yeah, and it's a little fiddly, and I gotta make another template, and our thickness threw us off, so I gotta make some adjustments.
But like the solidness that will actually make happen will make this align perfectly and be great structure for the LED panel. We can remove this at any time if we need to access the LEDs.
That's the idea.
For maintenance, right? And so easy.
Yeah, I think we've put a lot of thought into like, how do we service and fix things?
Exactly.
Which, that doesn't always happen.
It's an arcade game. It will need that, as I've learned in my limited experience maintaining pinball machines. You also have the cup holder
My holy
printed.
grail, the cup holder, yeah.
Look at that.
So you know what we did? There was talks of using ABS pipe. I just 3D printed the whole thing.
Not bad.
So it's this funky angle is what's throwing us off. Right. So this outside is sloped, but the inside is straight down, and it's also beveled to fit a pint glass. So that's my holy grail, and it's out of your way.
Yep.
I love it. And we also did, you found these fantastic 3D printed Atari knobs.
I found the model for the actual 2600 paddle. And so you found a way to mount the potentiometer on the board.
Now, the viewers out there may notice we are a little high off the thing here. So we got super long pots because we weren't exactly sure how much length we needed for both the knob and to get through this panel. So we were concerned about mounting this right in the MDF. So I made a little aluminum plate just for strength that it screws in. And
you cut that on your bandsaw?
Yeah, my little tiny bandsaw.
So that's great. That's perfect.
Yeah. And then we'll just cut this down.
Okay, and that's just some kind of plastic. That's easy, right?
Yeah.
Cool.
No problem.
And we're gonna print these in different colors, right? So we're gonna print the paddles in 6 different colors for the 6 different player themes.
Yeah.
We're gonna maybe do this in the same color, possibly. And the button is clear because we have a brand new way of lighting that up now.
Yes.
Right? So we realized that with this going through, what is this?
I need to drill those out.
Is this 3/4?
Yeah.
We couldn't go through that much wood and also feed the LED wire through the button. So
because it hampered it, and then the button would stick.
Right. Plus, yeah, having any wire going through there was really sensitive about whether it would cause any interference in terms of the throw. So I wasn't happy about that. So we have a new way of lighting the buttons. So it's going to go all the way down through. Will this fit all the way through right now? Nope. We're going to pop that through. And we're gonna light them from beneath rather than from inside using this ring that I found. I can only find this ring on eBay. So I ordered a bunch of rings that were approximately the right diameter.
But look at this.
This one, look at that.
It's
bam!
perfect.
I mean, right on top with so little tolerance.
This little holder that you came up with is great.
Yeah, so I 3D printed this little clip so we can actually screw it down into the MDF. And I soldered this was supposed to be a through hole.
I know that was a concern.
Yeah, because it only has these little pads on the actual LED ring. So I soldered this through hole connector, which mates with this wire. So that's my job today. I'm actually going to be doing a lot of soldering to make the wiring for all of the LEDs. But the cool thing is all the buttons now, 8 lights. Instead of 1, so that should be pretty damn bright. And
I think it's going to look good.
I think hopefully it'll look pretty cool.
I can't believe it exactly matches those.
I'm very happy about that.
Yeah.
So what do we? The next major step is going to be painting, right?
Yep. Once we got to drill the rest of these holes for the brackets and stuff.
Okay.
So I got to do one more revision on these light brackets, drill those holes, and then. I have to finish the hatch doors. I did these are our hatch doors for access in the bottom. So I found these cool little latches that they're completely adjustable. And you just use a screwdriver to like flip it open and close. And then it just clips in on the bottom. So I need to finish these, finish the bracket holes and a revision on those, and then we're pretty much ready to paint. And the nice thing is there's like really not any sanding we need to do with any of this.
Oh, that's good news.
Yeah.
And Monday which is 3 days from now, we are going to deliver all of the electronics that Other Ocean needs in order to finish the code. We are in the home stretch, my friend. Yeah?
Hey, everything fits. We have lights.
6 weeks away, less than 6 weeks. We're about 5.5 weeks away from the reveal.
I feel really good about that.
Good.
Like, I think we're good.
All right, then I feel good.
Yeah.
Thing's done. So we got a layer of primer, we did 2 layers of color, 2 layers of clear.
Yes.
All in all, about 2 days worth.
Yeah, and for the audience out there, I think spraying this with like a sprayer gun would have been far easier and turned out a little nicer, but
a little harder on our lungs.
We weren't set up for it, so we did the old-fashioned brush way, which works fine.
Had a good time.
Yeah, it turned out great. And So that leads us into also. Let me also during my research. One of the things I kept coming across is that you should prime the MDF with a solvent-based primer.
Because it's thirsty.
Yeah, because it's like a sponge and so it's porous and it likes to soak up stuff.
Yeah.
And you should definitely do that because I painted the underneath of the top here.
Yeah.
Without primer, just so it had something there. And boy, you would have had to put like 4 coats of paint on versus 2 if you hadn't done the primer.
So my concern with when we did the paint was we got a little bit of the paint inside the T-molding slot.
Yeah.
So you've started to add the T-molding to it, which is looking great. Has that been a problem?
No. So we cut all of these slots for the T-molding at Zach's. We have the arcade standard T-molding.
Yeah.
It has these little barbs on it. Putty knife, zip, right through.
Oh, so you clean it out super fast.
Yeah, cleaned out super fast. The T-molding is super easy to put in. You literally just start at one end and work your way around. Now, when you hit curves like this, you have to cut a little V-notch in there so it can go around the corner.
Oh, that's cool.
Which is easy. I just use like snips and...
And these have little ridges, so it actually sort of grips the inside.
As I go, I basically just kind of hammer it in as I go.
Nice.
Cut the little notches at any corners. And on some places, I would put a little, maybe like a staple or something. So I put a little staple here because this is a really sharp turn and to keep it anchored. But
nice.
It's actually fun. It was much more fun than painting.
You can say funner.
Yeah. So we're going to have that on all the panel edges, anything that's going to be exposed. We have our 3D printed brackets that I think we already went over these a little bit, but we went over some revisions with this. These are going to mount to all the fins and hold our LEDs.
They hold the whole front panel.
Yeah.
So I love that. I love that the front panel is not supporting anything.
Yep.
So what's left? We have to mount the brackets into the cabinet.
Yep. Final assembly.
Test out the LEDs.
Brackets.
As far as laser cutting, we still have to print the panel that goes on top of the LEDs
yes.
as well as the control panel.
Artwork.
So what we've decided to do there is take our black board and actually put a vinyl decal on each one of them that is colorized for the player.
Right.
And then we will laser etch.
Yeah. We're going to laser etch the rest of the artwork and the rules, the playing rules, to the back of the plexiglass that's going to cover this.
Transparent plexi.
So it's going to hold our artwork and protect the rest of this at the same time.
And so when we laser etch that clear plexi, it will turn white in those areas. So it will be a white on a color accent.
With the black. It'll look sharp.
I can't wait to see what that looks like. The only other thing is controls, which I'm wiring up in the shop. I'd love to show you real quick.
Let's go look.
Boom. All right, so I got this is the first test of the actual potentiometers connected to our little, input device.
Yep.
And it appears to actually work. I've got just the pots, just as if they were Atari 2600 paddles, which is the exact same wiring, running into our board. This is like the prototype board that we'll use, and they will actually. So I'm actually making Atari 2600 paddles. Like all of our controls will just look like that because our board is meant to use actual 2600 paddles to prototype with. So that's kind of the wiring challenge, is figuring out like how that all works. But I found this cool little. I don't even know what to call this, but it's a
nice
serial connector box where I can just wire all the wires, and if I make a mistake, I can unscrew and try a different button or try a different pin.
And that just has the old school paddle connector on it.
Exactly, which is just a D-sub connector, and if I could get that back in there we go. That's what we'll use, and it connects and it works. And if we hit our button, you hit yours.
Oh. Well, heck, we don't even need a cabinet now. This is awesome.
It actually works. If we could press our button at the same time, we'd be able to use it, which allows you to hold the ball.
Oh, yes, just like the original, right?
Yeah. And I
think this feels pretty good.
I think we can add a few more balls to the mix.
Oh.
Make it a little more challenging. But yeah, well on our way.
So dude, this is going to be amazing.
I just have to add some connectors to these wires so that we can easily take them out and replace them if we need to later on.
Yeah.
And then do it 2 more times, because there's 6 players, not 2.
I know. Repeating everything 6 times has been a little...
It's worth it. It's worth it, right? Don't tell me it's not worth it.
No, it's totally worth it.
Excellent.
It's going to be amazing. Other Ocean has done a fantastic job on this.
Yeah, I can't wait to show this to him. So the next step, once we get all this done, we're going to bring it over there, and then we will, basically work together to assemble it in-house at Other Ocean, and they got
to do their tweaks and everything for like the TV setup and all that stuff.
Yeah, and we'll have the sound working.
I can't wait to see your LED bar graphs going.
Final stretch, me too.
I know.
I can't wait to see that. So we've been prototyping using the 2600 paddles because they're readily available on eBay and anybody can pick them up. Mike had a ton of them over to Other Ocean. They're doing the code, so why not? So it was actually his idea to make our controller interface compatible with 2600 paddles. It's a great idea. So it turns out that these are 40 years old and they're kind of noisy, and every single paddle is slightly different. And some have a lot of jitter and some are a little more steady and some just don't do anything. So when I developed for the paddles that I had, and it worked well enough. But then when I sent it over to Mike, it turns out that they were very noisy, and it just turns out that not all paddles have been treated the same over the past 40 years, and they're a little bit noisy. So we revisited this circuit, and we ended up adding a lot more circuitry to our controller interface. We started out by adding a voltage divider to the paddle so that it actually gives correct voltage. And then we also added what's called an operational amplifier, or an op-amp. So that takes our little bit of current and it boosts it up so that our pins on the TNC can actually read it properly. Once we did that, I thought, well, that must be it. We're great. So then I sent it off, still noisy. So then we went back to the drawing board and added a low-pass filter to the input, which is basically a resistor and a capacitor, and they work together in order to smooth out the input that it gets before it even enters the operational amplifier. I learned all of this over the past couple weeks from our very good friend, once again, Zach Radding. Thank you, thank you, thank you. You are an excellent tutor, a great teacher, and we could not be doing this project without you, whether it's CNCing the cabinet or fixing the electronics.
So we're putting on the T-molding, and it's pretty straightforward, but it's exactly 3/4 of an inch wide, and technically this MDF should be 3/4 of an inch wide, but like most materials, like any woods and lumber, stuff like that, it's approximate. So this is actually 0.71. So if you look close enough, you can actually see that the trim kind of overhangs the edge a little bit. So that gives it an opportunity to get stuck or caught. But more importantly, what's happening is, since this has to slide into this slot, the T-molding is causing it to be a little too tight. So I picked up this thing, it's called a quad trimmer, and it's got little blades in there, and basically you can clamp it onto the T-molding, and just run it straight along there, and you can see it's trimming it as we go. So now we have a nice flush T-mold strip. And this can be used for other things like wood trim or other laminate covers that you might iron on as well. But it's been working really well, and particularly for these areas where it's a little tight, it's cleaning it up nicely. So we worked out all the kinks with putting the cabinet together. We have a lot of the electronic placement figured out, and Other Ocean's been off in their corner working on the software.
It's not fair that we've had it all to ourselves this whole time. We do have a deadline approaching in a matter of weeks. So the next step will be to bring our behemoth over to Other Ocean and install the software on the cabinet and see how things feel.